Hello everybody and welcome to this final day of the ROS2 Learning Week. I hope that you have enjoyed the week, but it's not over. So today is the day where you have to put everything you've learned into practice. So I hope that you have learned a lot during this week, because that is what is going to help you to solve today's final project. So welcome everybody. I can see here already some familiar names from the week that you have been here all the days working hard. So hello everybody. Also some new names, by the way. Maybe some of you have been shy in the chat, or you have been following the videos. I don't know. So let's then get started. So let me switch already to my computer screen here, so that I go to the streaming page and I can have the chat here. So what is the plan for today? All right. So today we are going to be doing a project where you are going to have to apply what you have learned during the whole week. You are going to have to be coding in Python, and you are going to have to create a ROS2 program in order to generate a specific behavior. Okay. Then today we are going to be working in a similar way as we have done the last 2 days, which is with a ROSject. Okay. So right now I want all of you to click here on this button in the description box below the stream. Here, the one which says open this talks ROSject. Okay, I'm going to click here myself right now. So as you already know, this is going to generate a copy of the ROSject in your account, which is permanent. So you are going to have access to this ROSject forever. Okay, not only today, but in case that you want to review it next week, next month, you are going to be able to do it. Okay, and also you are going to be redirected to this ROSject page, the one that I have right here. So I'm going to minimize the streaming menu here. You can leave it here. Here you have the video feed, the chat, in order to write comments, questions, whatever you want. I'm going to minimize it from my screen so that I have some more space in the project. So let me open the chat and everything here. There we go. Okay, then it's going to take a few seconds, even maybe up to a minute, in order to fully load. But all of you, let me repeat it one more time. Remember to get today's ROSject. Okay. So once you click here, you are going to be redirected to the ROSject page, which I am already on. And as you can see, mine is still loading. There we go. So now it has completely loaded. It has opened many things here, but I'm going to close all this. Just leave the notebook, because this is what you are going to get. Yeah, so you are going to see the notebook automatically opened once your ROSject fully loads. So we are going to be having a look at the notebook and presenting the project that we are going to be working on today. We are going to present today. And so as the last few days, let me just introduce you real quick to the ROS2 Basics in 5 days course, because all this that we have been doing is part of this course. It's part of our ROS2 Basics in 5 days course. So during this ROS2 Learning Week, we have covered, as you might already know, until the ROS2 topics. Okay, but in case that you want to push further your ROS2 knowledge, you can complete this whole course, where you're going to learn about other important topics such as subjects, such as ROS2 services, ROS2 actions, executors, callback groups, etc. All right, so you have the link here in case that you are interested. Then, so before getting started, let me know. So far, so good. Have you been able to open your ROSject? Yes, no? No, Sergi, the full ROS2 Basics course is not free. You can access it with a subscription to our academy. Yes, got it. F14, yes, all working fine. Okay, perfect. Then, so let's get started. So the first thing that we are going to do, as always, is to start our gazebo simulation. Okay. So in order to do this, we need to first of all open a terminal so that we can execute the corresponding commands. So remember, in order to open a shell, a terminal, you have to come here to the bottom right menu with all the tools available, and then click on the first one, which it's right here, which says web shell. I'm going to click here myself, and this is going to open for me a blank new terminal. And then here I can just directly copy the commands from the notebook and paste them into the shell. I'm going to do this right now, and then this is going to start the simulation and everything in just a few seconds. Let's wait and see if everything loads properly. Okay, there we go. So if everything goes okay, you should get a gazebo simulation like this one, yeah? With a Turtlebot 3 robot right here in this city environment, yeah, with these roads and signals and everything, okay? So, this is the simulation that we are going to work with today, okay? But maybe if you have been paying attention to the commands that I have executed here to start the simulation, you might have noted that this is not a ROS2 command, right? Because the ROS2 command, in order to launch, in order to execute a launch file, is ROS2 launch, not ROS launch, right? And if you have noted this, you are right. Let me tell you that you are right. Okay, so this is a ROS1 command. Therefore, the simulation that we are running here is based on ROS1, not ROS2. Okay? However, don't worry, because you have been learning during this week ROS2 for a reason, okay? So the program that we are going to be creating here, the project, is based in ROS2 still. Okay, so you're going to have to create a ROS2 program, but only that the simulation that you are working with is ROS1. So you might be asking yourself now, okay, so Alberto, you are telling me that this simulation is working in ROS1, but the programs that I'm going to be creating for the project are going to be in ROS2. So can ROS2 communicate directly with ROS1? Right? That would be the immediate question. And the answer to that question is no. Okay? So you cannot communicate ROS1 with ROS2 directly. Yeah? You need to do something so that you can communicate ROS1 with ROS2. Yeah, and this, what you have to do is basically to set up a ROS1 bridge. Okay? This ROS1 bridge tool is going to allow you to communicate nodes from ROS1 to ROS2. In this case, it's going to allow you to communicate the nodes of this simulation and the topics of this simulation with your ROS2 nodes that you create for the project. Okay? Yep. Are you following so far? Is it clear, the setup that we have right now? Yes, we have started, Ahmed. We have started, yeah. Okay, yes, clear, yes. Okay, perfect. Then, how do we start this ROS1 bridge, right? Because I want to be able to create my ROS2 nodes and to interact with this ROS1 simulation using my ROS2 program, right? All right, so the commands, in order to start the ROS1 bridge, you have them right here. Okay, so what we are going to do right now is the following. We are going to leave this simulation running here in the shell. Yeah, we don't want to close it because if we close it or we stop it, the simulation is going to die, okay, and we don't want that. So what we are going to do is to open another shell by clicking on this plus icon right here, yeah? So this is going to start another shell for me, and here I can write other commands, such as these ones that you have here in the notebook in order to start the ROS1 bridge, okay? So I'm going to copy here these commands and paste them directly into the shell. There we go. Okay. It's going to take some seconds to fully load the bridge, okay? Okay, there we go. So, what now? Okay, so now, if what I have told you so far is true, I should be able to communicate with, or at least visualize, be able to interact with the ROS1 topics and nodes from ROS2, right? So what I'm going to do here is to run a ROS2 command. For instance, ROS2 topic list. Okay, and what I can see is that actually I cannot see the topics, okay? But don't worry, because this is normal. Yeah, this is the regular behavior of the ROS1 bridge that we have just started here, which is the regular dynamic bridge, okay? The regular dynamic bridge is going to establish the connection only and only when there is some message published into one of the topics, okay? For instance, let me do a demonstration here. So I know that this robot has a topic which is scan, okay? Which is scan, and it is at the topic where the laser publishes its data, yeah? As we have seen in previous days. So I can tell you that this robot, this simulation, has this topic available, okay? So why I cannot see it if I run a ROS2 topic list? Well, it's because I have not generated this connection yet from ROS2, yeah? From the ROS2 side, there is nobody requesting access to this scan topic. Therefore, the ROS1 bridge has not generated this connection yet, okay? So what I'm going to do here from ROS2 is to force this connection, for instance, by subscribing to the scan topic, yeah? So I'm going to try to run here a ROS2 topic echo of the scan topic, okay? Then, okay, nothing is happened. This is telling me, okay, warning, topic scan does not appear to be published yet. Could not determine the type for the passed topic. Yeah? What is this type? Does somebody know? Could not determine the type for the passed topic. What does it mean by type here? Does somebody know? Laser scan, type of topic scan, yeah. Laser scan, the interface, very well, okay. Yes, yeah, you are right, the message, yeah, you are right. Okay, so in ROS2, at this point, I don't have information about this scan topic because the connection from the bridge side has not been created yet, okay? So if I want to subscribe to this topic, I need to specify the type, yeah? So I'm going to do this right here, okay? So I'm going to specify the type, which is sensor messages message, and then laser scan, as somebody in the chat was saying. Yeah, I'm going to do this. Okay, and now I start seeing the laser scan messages. Yeah, and furthermore, if I go to the bridge now, I'm going to see this. Yeah, so this has been created right now. Created 122 bridge for topic scan with ROS1 type sensor messages laser scan and ROS2 type sensor messages message laser scan. Okay, so now because I have executed the echo, so I am subscribing basically to the scan topic from ROS2, then the bridge says, hey, I need to create a connection from ROS1 to ROS2 for this topic. Yeah? Okay? Can you create a bridge with the wrong type, or will it fail? It's going to fail, Joe. You cannot. You cannot create it with the wrong type. It's not sensor message, Logan. It's sensor messages. Okay? If you want to know exactly, for instance, you can do a ROS2 interface list and then filter with grep for laser scan. Okay, then you can see here exactly the message type. Okay. Yep. Okay. Then yeah. So this is the behavior of the regular dynamic bridge. Okay. But just so that you know, you can run the dynamic bridge with a special argument here, which is bridge all topics. Yeah. So I'm going to show the behavior now, yeah? Remember that with the regular dynamic bridge, if I do a ROS2 topic list, I cannot see the topics, yeah? Until I specifically generate a connection, an interaction with the ROS1 topic, okay? If there is no interaction, then I'm not going to see the topics, yeah? This is done in order to save resources, all right? Then, what if I close this bridge, the dynamic bridge, the regular dynamic bridge, and now I'm going to run it again, but adding this argument, bridge all topics, okay? Let me execute it now again. Okay. So now, first of all, you can see that there are many more messages appearing here in the terminal, okay? But also now, if I come and run another, again, a ROS2 topic list command, here, what we are going to see is that now I can see all these topics, okay? So now I can see the scan topic, I can see the ODOM topic, I can see the TF topic, the IMU topic, okay, and you can run an echo of the scan topic, for instance, without having to specify the type, okay? Because now, by default, the scan topic is being bridged to ROS2, even if there is no request from the ROS2 side, the bridge is still done, is still generated, okay? So now we can regularly do a ROS2 topic echo scan and visualize the messages that are being published into the scan topic from ROS2, okay? Yeah? Is it clear, this concept of the ROS1 bridge? That we are generating this bridge between ROS1 nodes, which are the ones that are running this simulation. This simulation is based on ROS1, and our commands, in this case, that we are running in ROS2. So we need to know what type of message at least one of the robot topics has if we want to connect using the bridge. Well, if you are using the regular dynamic bridge, then yes, you need to know the message type. Do we have to create the bridges for our programs based on the topics we have, or the code is generic and can be used on all topics? I'm not sure I understand your question, Aladdin. So the bridge, you don't have to create anything. So you just run the bridge and that's it. Is it best practice to only bridge the specific topics you need, or should we normally bridge all topics? Yeah, the best practice is to only bridge the specific topics you need. That's correct. Yeah, I see that Ricardo has already answered to you. Yeah, because the more topics that you are bridging, the more resources that you are going to be using. Yeah, so it is always better to try to bridge only the topics that you need. Okay. No such file or directory error. And you have to be more specific, Takabarsha. Where are you getting this error? When running a command, or new motivation to work with Noetic and Foxy Humble? If I have some ROS1 packages that are related to a robot, can I use ROS bridge to transfer topics only? Yes, for sure. Yeah. In fact, the reason why we are using the ROS1 bridge today is because at the end of the class, we are going to connect to a real robot here. Okay? So we are going to be connecting to this real robot that we have here in our facilities, and I'm going to execute some code in the real robot. Yeah? Now, the real robot is working in ROS1. Okay? So that's the reason why I have introduced today the ROS1 bridge. Yeah. So yeah, if you have a real robot which is running in ROS1, you can use the bridge in order to be able to use the robot with ROS2 programs. Okay. When running the bridge all topics command, then you are probably running something wrong. So the command is like this. ROS2 run, ROS1 bridge, dynamic bridge all topics. Okay, make sure that you copy it properly. Okay. Exactly. It doesn't matter if the robot is in ROS1, you can bridge it and program it in ROS2. Exactly. All right. Then let's keep going. What else? Okay, then now we are going to introduce today's project. Okay? So what is the project that you are going to have to complete about? Well, I want you to create a wall following behavior. What does it mean? It means that you create a program that, combining the laser readings and the velocities sent to the Camembert robot, you generate a behavior where the robot is going to keep moving alongside the wall, generating a kind of square-like trajectory, okay? But always moving alongside the walls, yeah? You have an image here, see? So the end result should be something like this. This is what we are calling a wall following behavior, Yeah, it's going to keep following the walls and doing laps to this circuit. Okay, so what steps do we need to do in order to achieve this? So first of all, we are going to create a ROS2 package named wall follower. Okay, then inside this package we are going to include a ROS Python file named wallfollowing.py. Okay, so I'm going to start the project with you. Okay, I'm only going to start it, but then you're going to have to complete it. Okay, but in order to set up the basics of the project, I'm going to start it with you. All right, so let's go for it. Then, in order to create a new project, we are going to go to the source folder of the ROS2 workspace, as we have been doing, right? Okay, then here we are going to create a new ROS2 package named wall follower, right? So ROS2 package create, the name of the package is going to be wall follower. Then the package that we want to create is a Python package, right? So I need to specify the build type to what? If I want to create a ROS2 Python package, what has to be the build type? I meant Python, there we go. So I'm going to copy directly here. I don't like to write, so I'm going to copy Robotics solution directly from here and use it in my command. Okay, what else? I'm going to specify some dependencies, okay? Can somebody tell me which dependencies we know that this package is going to need based on the project that we are going to be doing? What dependencies 100% I'm going to need? RCL-Pi is one, okay. RCL-Pi is one for sure that we need. Okay, sensor messages, geometry messages, very well, very well. Okay, so yeah, I need sensor messages. Why? Because I'm going to be working with laser data, right? And the laser data is managed through the laser scan interface. And the laser scan interface is defined inside the sensor messages package. Yeah? And the same goes for the other one that you also said, which is geometry messages. Yeah? Why geometry messages? Well, because inside this package is where the twist message is defined. And we know for sure that we are going to be using the twist message in order to send velocities to move the robot. Right? And I think that with this so far, it's enough, okay? We could also add standard messages, but it's not really needed, okay? So we are going to leave it like this, and then let's create the package. Okay, there we go. So now I'm going to open the code editor so that I can have access to everything using a graphical interface. So let me open right now the code editor. Remember that you have the code editor tool right at the side of the shell, okay? So you click here in the code editor and it's going to open the code editor for you, all right? So now here inside my ROS2 workspace, I have the wall follower package, okay? And for instance, you can go to the package XML if you want, and you are going to see that here the dependencies that you indicated have been added, yeah? Okay, so let's keep going. What else? Okay, so inside the program, well, yeah, the other thing that we didn't do it yet is to, inside the package, include a ROS Python file named wallfollowing.py. Okay, so I'm going to go here inside the wall follower folder, and I'm going to create this wallfollowing.py. There we go. Okay, so now, inside this program, I know that I'm going to have to subscribe to the laser topic of the robot. Yeah? So inside this program, we are going to have to create a ROS2 subscriber, for sure. Okay? Then it also indicates here, it gives some hints, yeah? It says, in the callback of the subscriber, select the ray on the right, the one that makes a 90 degrees angle to the right with the front of the robot, and use it to know the robot's distance to the wall, yeah? So, well, yeah, we're going to need to capture some specific angles, especially the one at the right side of the robot and the one in front of the robot, okay? But yeah, so first thing that we know for sure is that we are going to have to create a subscriber for the laser topic, yeah, in order to get the laser readings information, the data, right? And another thing that I know for sure is that I'm going to have to publish velocities for the robot, yeah? And we know already that velocities are going to be published inside the command bell topic, yeah? So we are going to have to create also inside this wall following .py script, we are going to have to create a publisher that publishes twist messages into the command bell topic, yeah? And I'm going to publish these velocities depending on the readings that I get from the laser, yeah? For instance, a possible behavior is this one, yeah? So if the distance to the wall is bigger than 0.3 meters, you need to make the robot approach the wall a little by adding some additional rotational or some angular speed to the robot, yeah? Or if the distance to the wall is smaller than 0.2 meters, you need to move the robot away from the wall by adding angular or rotational speed in the opposite direction. And if the distance to the wall is between 0.2 and 0.3 meters, just keep moving forward. Okay? And how am I going to evaluate all this? Well, by using if statements, for instance. Okay? Yeah, and there are some additional notes here, like when the robot is moving along a wall, it can reach the next wall just in front of it. At that point in time, you should take into account how to progressively transition the robot from following the current wall to the next one. Okay? All right. In any case, step number 4 that we are going to do is to create a launch file to start our program, right? So I'm going to come to my package, to my wall forward package here. I'm going to create a new folder named launch. And then here, I'm going to create this launch file inside the launch folder. So right-click, new file. And again, it's not created inside, so make sure that you move it inside the launch folder. All right? Then, okay. So now it would be time to create the program, right? Then if you scroll down here to the appendix number 1, you are going to find it in your notebook. You are going to find here a starting program that I have created here for you. Yeah. So I allow you to copy this. Okay, and paste it here into your wall following program. Okay? Yeah? Then we are going to analyze this, and you can actually use this code as a starting point for the project. Okay? I can tell you that this is not the whole project. Okay? This is just a brief demonstration and a starting point so that you can use it as a template to complete the project. Okay? Or if you want, you can just do it from zero, okay? That's up to you. But I wanted to provide this code just in case that you want to have a template or a starting point, okay? Then let's quickly analyze what are we doing in this program, okay? Because basically what we are going to see here is how to combine a publisher with a subscriber in the same node, okay? Which is something that yesterday we didn't cover in the class, but I told you that you should do it as homework, yeah? So did you review the whole topics unit with the combination of publisher and subscriber and the custom interfaces? Yes, no? Did you check it out? No, says Sergi, more or less. Okay. Okay, then let's review it here together, okay? Because yesterday during the class we saw how to create a publisher in OneNote and how to create a subscriber in OneNote, but not how to combine a publisher and a subscriber into OneNote. Wojtek says, I did review it and made some mistakes along the way. I didn't manage to finish it before this lesson. Okay. Okay. Then let's have a look at this code, yeah? So what are we doing here? Nothing new so far, yeah? So we are importing RCLPy libraries, we are importing the node class, and we are importing the twist and the laser scan messages, which are the ones that we are going to be using, right? And then we are importing here as well some things related to the quality of service, yeah, that we explained a little bit about them yesterday, right? Then here we are defining our class, which is named exercise 21. And this is a very good example of bad naming, yeah? In day number 2, when we were studying about Python, we said that, I don't remember who it was, but one of you said that we should write our code as comments, yeah? And here, having this class named exercise 21 is a very bad example, because what the hell means exercise 21, right? So what name can I give to this class? To this Python class? Can somebody suggest me some names that I could give to this class, which makes more sense? Wall follower, okay, I like this one, wall follower. Let me use this one from Stefan. Okay, so I'm going to rename my class to wall follower here. Okay, but then I have to make sure to rename it everywhere it appears, right? So I'm going to do a Control F here inside my program, Control F, to find anything which is named exercise 21. Then I can, first of all, I can find this. Do you know what this is? What am I specifying here? Is this the name of the class also, or what is this? This is the node name. Node name, very well. So this is the name that I am giving to the ROS, to this ROS node. Yeah? So, so whenever I do a ROS2 node list, this is the name that it's going to appear, okay? So I'm going to also rename this to, let's say, for instance, wall follower node, okay? Yeah? Then I'm going to keep searching here through the program, and I can see here I am specifically calling the class name to create an instance, yeah? So here, for sure, I need to rename this to exercise 21, to wall follower, sorry, yeah? Then this is a variable where I am creating an instance of the wall follower class. So this one, for instance, I can rename it to, I don't know, to wall follower, just, okay? Wall follower. And then I have to rename also here, where I am using the variable, and here where I am also using the variable. Okay, there we go. So now this code has makes much more sense. Yeah, somebody who comes here and checks this program is going to say, okay, so this class has something to do with following walls. Okay. All right. Then, yeah, so here we are creating our wall follower class, and then here we have the constructor of this class, right? So what are we doing inside the constructor? Well, first of all, we are initiating a ROS2 node named wall follower node, yeah? Then we are creating a publisher object here, which is going to publish into the command belt topic twist messages. Yeah. Then we create also a subscriber, which is going to subscribe to the scan topic. Yeah. Using laser scan messages. So I am expecting to get laser scan messages from this topic. And also I am binding a method to this subscription. What does this mean? This means that every time that a new message is published to the scan topic, this method is going to be activated, triggered. Okay? Yeah? And then here I am setting the reliability to best effort. Yeah? Typically, the scan topics, the laser topics, are going to use a reliability of best effort. Okay? All right. Then what else? Down here, I am creating a timer object also. Yeah, we have already seen timer objects as well. So when defining a timer object, I need to specify two things: a timer period, which in this case I am defining it here, which is 0.5 seconds, and also a function associated to this timer. Yeah. Then in this case, this motion this motion method is going to be executed every 0.5 seconds. Yeah. Okay. Then also here inside the constructor, I am initializing a couple of variables. So first, I am creating a laser forward variable where I am going to store the laser readings corresponding to the forward direction of the robot. And also I am initializing here a twist message. Okay? Yeah? All right. What else? Then I need to implement my methods, right? So first of all, I'm going to start by implementing this move turtle method, which is the subscriber callback method. Yeah, the one that I have defined here. Yeah? So I am implementing it, and inside this callback method, all that I'm going to do is to update the laser forward variable with the range number 359 of the laser. Yeah? So I am accessing the ranges array in the position 359. Yeah? Why? Because I know that this is the position that corresponds to the front of the robot. All right? So everything that I am doing here in this callback method is this. Yeah? So every time a new reading comes, I'm going to capture only the frontal reading and save it into this laser forward variable. Okay? Then, what am I doing in this motion method? The motion method is the one which is associated to the timer. Yeah? Then inside this motion method, what I am going to do is to evaluate the value of this laser forward variable. Yeah? So here I am saying, okay, if the value of laser forward is bigger than 0.6 meters, I'm going to set a linear velocity, meaning I'm going to move the robot forward at 0.2 meters per second. Yeah? Now, if the laser forward value is lower than 0.6 meters, but higher than 0.3 meters, so if it is between 0.3 and 0.6, I'm going to still move forward, but a little bit slower, yeah? Why? Because I am getting closer to something, in this case to a wall, yeah? So I'm going to keep moving forward, but I'm going to reduce a little bit the speed to 0.1 meters per second, yeah? And then finally, else, so if the laser forward distance to the wall is lower than 0.3 meters, so if I am detecting some obstacle in front of the robot which is closer than 0.3 meters, than 30 centimeters, then I'm going to stop the robot. Because I don't want to crash against it, so I'm going to completely stop the robot. Okay? So this is the logic of this program that I have created here. Yeah? Then finally, in the main function, I do what I am doing always. So I initialize the ROS communication, I create an instance of the wall follower class, I spin this node, and then whenever somebody kills this node, I'm going to destroy the node and shut down the ROS2 communication. Yeah? So the expected behavior whenever I run this program is that the robot is going to start, let me reset this. Yeah, as you can see, if you have the simulation running for a time, the robot is going to start rotating by itself. So let me try to reset the world completely. There you go. Okay, then if everything goes as expected, what I would expect from my program when I execute it from my ROS2 node is that the robot is going to start moving forward, yeah? Then, as it gets closer to the wall, it's going to lower its speed, right? And then whenever the robot is closer than 0.3 meters to the wall, it's going to completely stop, right? That is the expected behavior based on the analysis that we have done here to our program. Yeah? Does it make sense? Do you understand the structure of the code? Makes sense, says Logan. Also Soraya, Joshua, Wojtek. Okay. Excellent. Then let's try it out, right? If it's supposed to do this, let's try it out. So what shall we do now? Well, first of all, we need to fill in the launch file. Now, I don't remember about this, so what I'm going to do here is to open my notes from here. No, sorry, not here. I'm going to open my notes here from the course. So ROS2 basics in 5 days Python. Okay, so let me come to one of these units in order to get the notes. All right, so here I have a template for the launch file, right? Then I need to change it, of course, to adapt it to my package. So the package name in this case is wall follower, right? Wall follower. Then the executable, I have not created it yet, but I'm going to call it something like wall following exe, something like this, okay? And then the output to the screen. This is okay. All right. Then additionally, I need to update the setup.py, right? In order to generate the executable. So let me look here for an example also. I don't like to remember all these things by heart. So I need to add these imports. I need to add this line here in order to make sure that I install the launch files in the system, right? So I need to add this line here. And finally, I need to generate the executable with this line here, right? So I'm going to add this here, and then I need to change it, yeah? So this is going to be the name of the executable generated. So here I have to make sure that I have the same name that I am using here in the launch file, right? So let me copy this, wall following exe. There we go. Then the package name, this is the package name. In our case, it's not publisher package, but it's wall follower. So I need to update this as well. And then finally, this is the name of the Python script, which in our case, it's wall following. So we need to also update, I need to also update this. There we go. Okay. So from the main function of the wall following script, inside the wall follower package, I'm going to generate this executable here. Okay, so I think I'm ready to go. So let me come here to the root workspace and compile my package. So call compiled, packages select, and wall follower. Let's see if this if this gets compiled correctly. Okay, no error so far. So let me source this. Okay, and then we are ready. Okay, so before that, I'm going to stop everything. Okay, just to start fresh. Then, yeah, let me stop. So the simulation here, and this here. All right. This is not required, okay, but I just want to have everything fresh here. Okay, so let me relaunch the simulation. There we go. Perfect. Let me orientate this here so I can see better the wall behavior. Okay. So what now? Can I execute my program already? ROS2 launch, wall follower. Start. Okay, so can I execute my program already? Or no? I think so. Did you source it? Yes. I source it. But there is something that I am missing. There is something that I have not done. All topics bridged? No. Yeah. So I have started the simulation here, but the bridge, I have not started it yet, right? So I have to bridge it. Yeah. And which one do I have to use? The regular dynamic bridge? The regular dynamic bridge, or the one with the bridge all topics argument? Which one should I use? The regular? Okay. Yes. So I use regular dynamic bridge and bridge scanner and command bell. We are lazy, so all topics. Yeah. Okay. So we could use any of the two of them. Okay. Ideally, the better option is the regular one in this case, because it's going to be more ergonomic in terms of resources. Yeah, it's going to save more resources. Okay, so in this case, since we already have created the program, we know all the topics and everything, we can run this one, and it's going to be lighter. Okay. So let me run the regular dynamic bridge here. Okay, and now I'm going to run my program. And let's see what happens here in the simulation. Okay, so the robot starts moving forward. Now it lowers a little bit the speed. And now around here, it should stop. There we go. Yeah? See? So now it is at 0.2526, yeah, of the wall. So it has stopped. Yeah? So, well, we can say that it has accomplished the expected behavior, right? What we were analyzing in the code here has been reproduced here in the simulation, right? So, yeah, the code is working as expected, so we can say that it's working correctly, right? Yeah? May I explain why ROS2 uses call build instead of cutting make? That's because of this, because of design time decisions. Okay, so you can read some about it in in the design pages of ROS2. I don't know if I'm going to find them now. I think it's here. Here is where it analyzes everything, and then it shows why it has chosen over Qualcomm build. I think it is here. Yeah, but it's a longer story, and it is because of design decisions. Yeah, so someday there will be so much excess processing power that future generations will wonder why the ability to only bridge certain topics exists. We will scoff at those. Yeah, that's an interesting take, Joe. Could you please show the launch.py file when you have a second? Want to make sure I have it set up properly. Yeah, sure. So here you can see the launch file. Yeah, that's also right, Sergi. That's also right. Yeah. Okay. So what should we do now? Okay, let's go back to the project. Then the part one of this project is to test the program in the simulation. Okay? So this is what we have just done. Yeah? Not the wall following behavior, but just a smaller version of it. Yeah? So this is important because this is usually the way that you are going to have to work if you become a robotics developer. Yeah. So first, it is always advisable to test your programs in a simulated environment. Why? Because in a simulation, it doesn't matter if something breaks. It doesn't matter if your robot crashes against the wall. Yeah? So you can do as many tests as you want without having to worry about anything, right? So on the other side, if you start testing your program in the real robot, if something goes wrong with your program, you can break the robot, yeah? And breaking a robot, depending on the robot, can mean losing thousands or tens of thousands of dollars, euros, whatever you want to say. Okay, so always it is better to start working and testing your programs in a simulated environment. Yeah. Now, once your program is working as expected in the simulated environment, then you can move to the real robot. Yeah. So at this point, we have been testing in the simulation our code, and we have seen that the behavior, it is what we were expecting from the program, right? So we can say that the program, that our code is working correctly. Okay, so now it is time to go to the real robot, yeah? So what I'm going to do now is to connect to the real robot lab that we have here in Barcelona, remotely here from the project, yeah? So I'm going to stop everything, yeah? I'm not working anymore with the simulation, so I'm going to stop the simulation, yeah? Now the simulation, I don't need it, right? Now I am moving to the real robot, yeah? So I don't want the simulation for anything. Okay, so let me stop the simulation. I have stopped the bridge also, and I have stopped my program, right? Okay, so now here you have, down here in the notebook, in the appendix number 2, you have the steps to book a session with the real robot lab, okay? Here you have all the step by step. Yeah, I will show it later if you want. But here in my case, I already have a session booked. Yeah, so all I have to do is to come here, yeah, to this robot icon and turn on the robot connection. Okay, so I'm going to turn on my robot connection here, And now I am directly connecting to the real Turtlebot 3 robot lab, okay? It might take some seconds. It might take some seconds, but it's going to connect to the real robot. You will see it in a moment. Okay, there we go. Connection has been made. Okay, excellent. So as you can see now here, automatically I can see the cameras of the real world. Yeah, this is the real Turtlebot. Yeah. Also, I have here a joystick, which I can use directly to move a little bit the robot around. See? You can move it around a little bit like this. Okay. So I'm going to move it to, I'm going to control it a little bit just to put it in a similar place as I had it in the simulation, right? Oop. Okay, there we go, more or less. Let me move it a little bit like this. Yeah, there we go. Okay, here it's okay. Stop it. Yeah, so this is the real robot, okay? And right now, I am connected to it from the project, okay? So, let's try our program with the real robot, right? Okay, then, what is the first thing I need to do here? Can I run my program directly? Here? My ROS2 program, can I execute it directly? Yeah, here it's going to take a little bit longer to load. Let me open it again. There we go. We first need to bridge it. Very well. Wojtek is right, yeah? Because I told you before that this robot is running in ROS1, right? So if we want to run it, we need to first bridge it, right? So we are going to do that. Remember the commands to bridge it. We had them here in the notebook. So here it is, yeah? So let me, first of all, run here the bridge, the dynamic bridge. Okay? Let's wait a few seconds until the bridge is created. There we go. Okay, and now I should be able to run my program, right? So let me source my ROS2 workspace where I have the program. This camera has died, by the way. I think, for some reason. Okay, doesn't matter. We are going to check it here. Okay, so ROS2 launch wall follower and start wall following whatever. There we go. Okay, so let's run it. And let's see what happens here in the real robot. Okay, so the robot starts moving forward and eventually it didn't stop in time. Okay. Can you imagine why it was that? Can you imagine? Let me move the robot back. I have an idea of why it happened. I'm going to do some modifications to the code to prove it. There we go. Let me see the chat. Latencies is one reason. Too fast is another reason. It was moving too fast, so it didn't manage to slow in time. 0.5 seconds of motion is too long. Very well, very well. All of you are right. So, okay, let me come to my code and let's do a couple of changes. First of all, I'm going to make my robot move slower. So instead of 0.2, I'm going to move it at 0.1, and here I'm going to move it at 0.05, for instance. Okay? And then also I can increase here a little bit the timer period, right? So that this motion method is executed more times. So let me reduce this to 0.3, for instance. Or 0.2, even 0.25, okay? Now, let's come here, let's recompile, very important, we need to recompile, call build. Okay, and this is very common, okay? So this is very common. It's going to happen that when you try your programs in the real robot, it's probably not going to work the same way that it does in the simulation. Yeah, this is known in robotics as the reality gap. Yeah, there are always differences between the simulation and the real world, which you have to take into account. Yeah, but at least we have seen that the behavior is more or less the expected, but we have to tune a little bit our program to make it work properly in the real robot, right? So I'm going to try it one more time now with these modifications. Okay, there we have the robot. Let's run it one more time. There we go. Okay, now it's not moving for some reason. Okay. Probably something happened to the bridge. So I'm going to restart the bridge, okay? Yeah, see here? It has removed the bridges. Okay, so let me restart the bridge here. Sometimes the ROS1 bridge dies, okay? If the program that you are using, you kill it and these kind of things, it can happen that the bridge dies, okay? So let's start again the bridge. And let me run again my program now. Oh no, what happened here? What happened? Okay, that was strange. Let me start again the bridge. Okay, let me check ROS2. Okay, there we go. Okay, so there it goes, the robot. Now it's going much slower, as we can see. So it is approaching the wall. Okay, so one of the problems is that the values received from the laser are too slow to come. Okay, that's interesting. That's very interesting. So let me go back. You can see that the updates from the laser are very, very slow. So okay, there we go. Okay, so okay, let me check this. Yes, see, so the values here are updated quite slowly. Okay, so I'm going to reduce this still a bit more, 0.8, and this to 0.4, something like this. And I'm going to increase a little bit more the speed of my loop. So let me recompile. Okay, and I think this time we're going to make it work properly. Okay. Also, there is one inherent problem from this, which is the latency. Yeah. So because of the latency, obviously we are going to have some delays and everything. Okay, but that is expected. Yeah. We can work around it more or less. Yeah. So let me run the bridge one more time, And let's see if now we can make it work properly with these last modifications. There we go. Okay, there it goes, the robot, 1. Okay, we need to update already, 0.6. Yeah, now it is stopped properly. Okay? Also, this is a very good suggestion, Zacharias, to increase the distance threshold. This is another approach, very interesting approach, yeah. Let me see here. Sensor under the vision sensor. 3D LiDAR will be a nice addition though. There are 3D LiDAR are really good. Okay, I can see that you are here conversating between yourselves. Can you put the bridge in the same launch file? Yes, you can. You can put the bridge. And why not Symlink install? Well, just for simplification, Symlink install, you can use it, but it has some issues as well, Symlink install. It doesn't work perfectly. Yeah, this is because, Jeff, this is just because it crashed. It crashed with the wall, yeah? So actually, the distance to the wall was lower than the minimum range, and then it turns to infinite. Increase the distance threshold, okay. Some suggestions here. Okay. Yeah, exactly. This is the main problem, that my laser distance jumps versus changing smoothly. Yes, and this is because the latency, basically, okay? So you need to adapt a little bit your program to this scenario, okay? All right, then let me stop this. I'm going to stop this, okay? And I'm going to stop the real robot connection here. By coming here and turning off, okay? So what now? Okay, let's go now back to the project, and basically this is a simple example, yes, of a combination of a command belt publisher with a LaserScan subscriber. Okay. This is a minimal example where we are moving the robot forward, yeah, until it finds a wall, and then it stops at a threshold distance, okay? Now, what you have to do is to complete this program in order to generate the wall following behavior, the complete wall following behavior, yeah? So that is your work to do, okay? Then, how should you complete this project? Just as we have done now, yeah? So first of all, you try your program in the simulation, okay? Once the program is working correctly in the simulation, you are going to be able to book a session here in the Real Robot Lab. Let me show you very quickly how it is done. So you can come here to Real Robots, yeah? Then come here to the Turtlebot. In this case, this is the one that I have been using. Book now, yeah? And then you select here the time, day and time that is better for you, okay? Then continue and confirm, okay? Once you do this, you are going to have the booking, so you are going to be able to, whenever you come to your project at the time of your booking, you are going to have this option to turn on the connection to the real robot, yeah? So, first, create your program, your ROS2 program here. You can use this one as template, try it in the simulation, and once it is working in the simulation, you try it out in the real robot. And then you are going to have to modify some things, just as I have done today, okay? So that is the project, and during the next week, okay, and only during the next week, we are going to open the lab, the Turtlebot lab, we are going to open it to everybody. Yeah? So everybody, free users, are going to be able to connect to the lab. So all of you are going to be able to test it. Okay? Now, yeah, so before finishing, as I have been doing these last days, let me remind you just for a moment about our Robotics Developer Masterclass, which is a learning program that we have created to teach you all the skills required to land a job in a robotics company. Then you are going to learn from novice level to expert level. So no previous requirements are required. So also, you are going to learn by a combination of lessons like this one we are doing today using simulations, and also practice with the real robot labs. Yeah. So, like we have done in today's session, you are going to learn by combining simulations with real robots. Yeah. You are going to work with the Turtlebot city, for instance, the one that we have used today, but also others which are much more complex, like an industrial environment with a mobile base, a robot manipulator arm, the cyber world also, and others. Okay. Then in this masterclass, you are going to learn C++, lots of C++, but also other very important topics such as Docker for robotics, robot navigation, robotics theory, such as robot control, robot mobile kinematics, continuous integration, and many, many other topics. Also, at the end of the masterclass, you will enroll a 3-month internship in a robotics company in order to have an entry point into the robotics industry. Down here in the webpage, you can have a look at some of the companies that are our partners and that are available for our students to do their internships. Just some of them, but there are many more. Also, let me remind you that you can take this masterclass at your own pace. There are different formats, and depending on your time availability, you are going to be able to do it in 6 months, which is the fast pace, but also at in 8 months, 12 months, 24 months, depending on your time availability. Yeah, and just to finish, the next batch of the masterclass is going to start in September. So if you are interested, you can enroll in this webpage, which I'm going to share with you, with all you here in the chat. And yeah, so basically that is everything. Let me check the last messages. If we are running ROS on a standalone with our own robots, how do we set up the bridge? You mean the ROS1 bridge? It's the same way. Joe, it's going to work the same way. Okay? So this ROS1 bridge is not something special that we have created, but is a package that it's available in ROS. Yeah, you can come here and you can see, you can download it, compile it, and then you can run the dynamic bridge just like this. Okay? Only got 15 min left. I don't know what you mean here, Stefan. Can you show us the setup by and launch to copy real fast examples? Yeah, but you can take them from your other projects or whatever. So this is the launch file. Okay, it's just the same as the launch files that we have been creating in the past days. Okay, just the same. Just changing, of course, the executable and the package name, but it's the same. And this is exactly the same that the ones that we have been creating in the past days as well. Yeah, with this line in order to install the launch files into the install folder, and this line to generate the executable. Nothing strange here. I have not done anything new, okay? Just using the same that we have done during these days. Thank you very much. Thanks. I suppose this is for the lab, for opening the lab. I have to go, but before I do, I want to really thank you for this week's lesson. It was a great experience. Bye to you all. Thank you, Wochte. You have been a great student as well. Care. How much time a day and how much money a course is it? Okay. The time it depends. There are different schedules, Sergi. So if you want to finish it in 6 months, you have to go for 40. I would say 7-8 hours a day minimum. Okay, so full time. If you want to finish in 6 months, but then you can take a slower pace and do. I don't know. If you want to do 3 hours a day, then it's going to take you. I don't know. 16 months, something like this. I don't know, but it is adjustable to any pace. Okay, it just depends on depending on the hours that you are able to dedicate to it. You are going to finish it sooner or later. Ahmed, this is because you have not installed the launch file. Yeah, see, it says that it doesn't find your launch file in the shared directory. This means that you have not added this line. Yeah, either you didn't add this line in order to install the launch file, or either you don't have your launch file inside the launch folder, which also could happen. Yeah. Okay, all right, then I'm going to leave it here for today. So just remind you that this project that I have shared today with you, this project is yours forever, okay? So you can keep working today in the project if you want. You can keep working in creating this wall following code, but you can work during the weekend if you want, keep working next week, especially in order to finish it, to have something working that you can test in the real lab. All right. So yeah, that's going to be everything for today and for the ROS2 Learning Week. I hope that you enjoyed it. I hope that you, especially that you have learned a lot during this week. It was my pleasure to share all these classes with all of you. Many great students during this ROS2 Learning Week. And yeah, so take care. We are going to see again soon. Remember that next week, also next Friday, we have the ROS Developers Day, in case that you want to check it out. Very, very interesting event with many great speakers all related to robotics and ROS. And yeah. So, as I always say, take care and keep pushing your ROS learning. Bye-bye.